I'd like to focus on the decisions that the firewall is making regarding layer 3 routing and come up with a really good way to understand best. Because at the end of the day, when the router, or in this case, firewall A, is making a decision about how to forward a packet, which egress interface it's going to use, it's going to choose the quote unquote best route. And when it comes to the concept of best, let's use an analogy. Let's say we have some advice that's coming in from two different people, from person one and also from person two. So let's say person one, let's say it's about investing. And they say, you know what, it's a good idea to invest. And that's all they say. And it's very vague. And over here, somebody says, well, I've had 20, 30 years experience in this business, and I think you should go ahead and buy these specific kinds of index funds, and you should hold them for a period of time, and as you get older, take less risk, and it's more specific. So over here, it's vague, and over here, it's very specific. So assuming that the person over here is accurate, which of those two would be the quote-unquote best advice? And the answer is the one that's more specific. And when it comes to routing on the Palo Alto firewall, it's just like that as well. If it has a bunch of routes that it could use in its routing table, it's going to choose the best route, which is the one that's most specific. So let's narrow that down a little bit and talk about what does that mean, more specific. Let's take this routing table here on the firewall A. It has a directly connected network for 10.11 with a 24 mask. It is directly connected to this network here, 10.12.0. So that's in the routing table because it's directly connected. It's got the DMZ of 10.15.0.0. That's in the routing table. And it's there because we configured an interface with an IP address, for example, 10.15.0.51 with the 24-bit mask. And as a result, it believes it's on the 10.15.0 network because of how we configure the interface. It also has a directly connected network of 23.1.2.0 with the 24-bit mask going through service provider A and also through service provider B with 24.1.2.0/24. And then we also have on this firewall a default route that says this for IPv4. Effectively, if none of the other routes match, go ahead and use the default route, which has the next hop of 23.1.2.1. Now, as far as best is concerned, let's imagine this client is trying to do a ping out to Cloudflare at 1.1.1.1. So that packet comes into the firewall on interface 1/2, which is part of the inside zone, and the firewall is looking at the destination address and is considering its routing table. It doesn't match these three octets, it doesn't match these three or these three or these three. The destination here does not match on any of these other routes, so it's going to use its default route. Think of it like a last-ditch effort. If nothing else matches, it's going to use the default route. However, let's add some more static routes. So this is a static route, and let's add two more. Just in theory here. Let's add a default route for 1.0.0.0/8 and 1.1.0.0/16. And let's say that the next hop for the 100/8 with 24.1.2.1 as the next hop, and the static route for 1100 with the 16-bit match, the first two octets effectively, that the next hop is going to be, let's say, this server, which wouldn't be the real, a real good decision, but just for demonstration purposes, let's say that 10.15.0.100 is the next hop, which would imply sending out this interface in that direction, which, by the way, wouldn't work for getting to Cloudflare, but this is just an example. So now, once we have these static routes configured and we click on commit and we let that commit complete, then when the client pings 1111, the firewall, as it receives that packet on 1/2, it now considers the destination and its routing table, and the default route is no longer the best match because there's two routes that are even more specific. This one right here is 8 bits long, and so that's matching on the entire first octet, and this one right here is even matching on more. It's more specific. So best in a routing perspective means the longest match from the routing table. And as a result, that's the longest match. We're matching on the first 16 bits, and that's the one the firewall is going to choose from its routing table. Now, unfortunately, based on the next hop, the firewall is going to forward it up here to this poor server at .100 who says, I don't know what to do with that. In any event, that's how it makes its decisions. So if it's wrong or incorrect, that's going to cause the traffic to go the wrong direction. Now, the cool thing is in the logs, if traffic really is being routed, for example, out interface 1/5 here, that's great to know in the logs because then we can go back and take a look at the routing table and we can ask ourselves a question, why did the firewall choose to forward in that direction? out interface 1/5 and go back to the routing problem, or in this case, the static route that's causing the forwarding problem. And this firewall is not responsible for downstream devices and how they're going to handle the traffic. The firewall is just using what it knows about based on what it's learned either through static routes or dynamic routing protocols or what it's directly connected to make its routing decisions. And again, it's based on the longest match, looking at the packet coming in, which route in its routing table matches the most bits of that from left to right, and it's going to use that route to make its routing decision. So I thought what would be fun is to go ahead and demonstrate this in action. So currently we have our default static route going through service provider A, but we don't yet have these two static routes for the 1.000 and the 1100, 8 and 16 bits respectively. So what I'd like to do is, before we create those new static routes, let's take a look at the routing information, both at the GUI and the CLI for this firewall, before we add these static routes, and then we'll add the static routes and then compare and contrast the difference. So let's first start at the Raspberry Pi, and let's do a ping out to 1.1.1.1, and then let's also see if this will cooperate with us. Let's do a trace route out to 1.1.1.1. Let me also do a -n for don't bother doing name resolution to 1.1.1.1, and there's our path going out. So the first hop is the firewall interface, and to make sure we're on the same sheet of music here, it's the interface 1/2's address. That's the first hop in the path. And then the next hop, based on the routing table, should be 23.1.2.1, which is through service provider A. So there's that next hop, 23.1.2.1, and then it's looping back through my home office network here, and then off to my service provider after doing some additional NAT there, and then onward and upward till it finally got to its final destination. And here where it timed out, we had some devices that weren't responding with the ICMP messages indicating that the time to live had exceeded. So here's the firewall. If we want to look at the routing table, we could do a show routing route. So there's our command right here, show routing route. And that's showing us the routing table, but that's not the winners table. The winners table is the FIB, the forwarding information base. And the command to see that is this one right here. It's show routing FIB for forwarding information base. So we have one virtual router, and that's what we're looking at here. Here's the name of that virtual router right there. There's the 5 interfaces that are allocated and part of that virtual router. And here's the route table. So here are the flags. If we scroll down, here are the routes. So here we have our default route with the next hop of service provider A, and the egress interface to reach that next hop is Ethernet 1/3. Then we have the 10.11.0 network, and the 10.12.0 network, and the 10.15.0 network. It's also including some host routes as well. This little H right here, effectively it's a 32-bit route for the actual interface itself. And then for the service provider, we have the 23.1.2 and the 24.1.2 networks reachable via those respective interfaces. So if we want to see the forwarding information base from the GUI, it would look like this. Here in the GUI, we'd go to network. On the left, we'd go to virtual routers. And then with our virtual router here on the far right, we'd click on more runtime stats. So we'll click on more runtime stats, and then here's the routing table. If we click on forwarding table, here's the forwarding table right here. So if we want to look for a specific route, let's say we had thousands of routes, we could just go ahead and put in, for example, 10.11.0.0 with a 24-bit mask, press enter, and it would filter and show us that specific route. And where it says next hop is 0000, that implies that we are directly connected to that network through Ethernet 1/1. If we want to look for the 12 network, we go ahead and change that to a 12, press enter, and then it shows that that's reachable out Ethernet 1/3 for that directly connected network. Or if we want to look for the default route 0000/0 and press enter, and that will show us our default route. We can also do the same type of filtering here in the route table, and that way if we had routes, even ones that were not actively being used, they would show up right here. So again, the forwarding table is like the meat and potatoes regarding what the firewall is actually using to make forwarding decisions. So when the client was sending packets to 1.1.1.1, it didn't have a better match on any of the other routes, and so it used the default route, and the egress interface was 1/3. So back at the CLI, we have a couple other tools we could use, including the test command. So we can use the test command of test fib lookup, virtual router, the name of your virtual router, and then the IP you want to test, and that's going to show us how it would forward based on the current routing table. So here's the destination. So the next hop would be 23.1.2.1. The egress or outbound interface would be 1/3, which is at 23.1.2.51. Hey, thanks for watching, and subscribe right here to get the latest information from CBT Nuggets. And if you're new to or considering a career in the world of IT, head on over to CBT Nuggets and sign up for a free trial.